Okay, so today we're going to enter information into our notebooks about fractions. We're starting a new unit today on fractions. So you see in front of you the learning targets for today and our title. So if you need to pause the video and go ahead and write that in the correct page in your notebook, then do that at this time. We're going to start with a review of what a fraction actually is. You all did fractions in elementary school, and you should have learned that a fraction is a comparison of a part and a whole. Now it's important to know what is what. So there are two parts to a fraction. There's something called the numerator and there's something called the denominator. The numerator is the top of the fraction, and this represents the part. The denominator is the bottom of the fraction, and this represents the whole. In elementary school, you may have done something called modeling of fractions, and that might have looked something like this, where you draw a picture, and you see this has 4 parts to it, so that means that each of these is fourths. And then if I shade in this one, then that's 1 out of 4 shaded in, so that means 1/4. You might also have seen them in a square or a rectangle format, so it might look something like this. And since this one has 3 pieces, that means it's in thirds. And if I shade in this one and this one, then that means that 2 out of 3 are shaded, so that's 2/3. You might also see it that looks something like this. If I do this, there's 4 pieces, that means they're fourths, and there are 2 shaded in, so that's 2 out of 4 or 2/4 shaded. You might also just see circles. So you see that I have 5 circles, and if I shade in those, that's 2 out of 5 shaded, so that means 2/5 of the circles are shaded. So we're going to review 2 basic principles today. The first is simplifying fractions. And simplifying fractions means that we reduce our fractions by the greatest common factor of the numerator and denominator. And I'm going to abbreviate right there. So we typically start with a real easy one. So if I give you this one, 4 and 6, or 4 out of 6. Most students are pretty well aware that 4 and 6 share a common factor of 2. So if I divide the top by 2, 4 divided by 2, that gives me 2. And if I divide the bottom by 2, 6 divided by 2, that gives me 3. So that gives me a new fraction of 2/3. Now, this means this is simplified. I always want to check to make sure that it is simplified to its simplest form. Since 2 and 3 do not share any other factor except for 1, then that means this is the simplest form of 4/6. Sometimes you get a larger fraction, like 42 over 56. This is more typical of what you'll see in middle school. You'll see the larger fractions they have to work with. So you kind of think to yourself, do you know of a number that would work with 52 or 56 that would also work with 42? If you don't know your times tables, this is going to be difficult. I see that they're both even, so I could start with 2, but I also know that both of these are divisible by 7. If I divide both of these by 7, 42 divided by 7 gives me 6, and 56 divided by 7 gives me an 8. A lot of students will stop here, but I realize that these 6 and 8 are also even, which means they have to be divisible by 2 again. In other words, 6/8 is not the simplest form of that fraction. I have to keep going. So now I'm going to go 6 divided by 2 is 3, and 8 divided by 2 is 4. So the simplest form of this fraction is 3/4. The last example that we're going to do under simplifying fractions looks something like this. It says 15/19. So now I have to think about what are some factors of 15. So I know that 1 times 15 will give me 15, but that doesn't really help me. So I think 3 times 15. So I try to see if either of those numbers will work with 19. You quickly begin to realize that 19 is a prime number, and the only way to get 19 is 1 times 19. So that means this one cannot be divided, and this one is already in simplest form. The other skill that we're going to work on today is called equivalent fractions. And equivalent fractions is just a fancy way to say that you have 2 or more fractions that have the same value. Two or more fractions that have the same value. Notice that says value. It doesn't say they are the same numbers. It just says that they mean the same thing. So you're going to see these in a variety of ways. So I'm going to show you several ways today. The first one, they'll give you one fraction, and then they'll give you a part of the second fraction, but you notice you're missing a number. So you're basically looking for number patterns here. You say, how is it that I can get from my known denominator to my other known denominator? And you think, oh, well, that's pretty easy. I could just do 5 times 3, and that gives me 15. So if this is an equivalent fraction, which means they have the same value, I need to hold that value the same. So I'm also going to do the top times 3, the numerator times 3. So that numerator of 2 times 3 means that my equivalent fraction is 6/15. You might also see it where the missing number is on the bottom, or the missing number is the denominator. So what if I gave you 4/5? And let's say I just put a box there. So you have to ask yourself, can I jump from a numerator of 4 to a numerator of 100? Guys, this is a skill that we're going to use all year long. So you have to really begin to think about relationships between numerators here. So if you know anything about 4 and 100, you know that you can do 4 times 25, and that gives you 100. So in order for this to be an equivalent fraction, I have to also do times 25, and 5 times 25 would give me a 125. So my missing number here is a 125. So I just wrote it in the little box. And then sometimes you will see it where the missing number is in the first fraction. So you might see something that looks like this: 4 and a missing number, and 32/40. So it's really no different. You're just trying to figure out how is it that I can get from here to here. So I have 4 times what gives me 32? Well, I know that that is a relationship of times 8. So something times 8 has to give me 40. Well, if you know your times tables, you know that 5 times 8 would give me 40. Now, probably the hardest equivalent fractions for students are the ones where you have a bigger fraction first, and a smaller fraction second. So students tend to panic with these. It's like they can't figure out how is it that I can get from here to here. It's obviously not multiplication because my numerator is getting smaller. So now you begin to think about how is it that I can get from 30 to 5? Well, that either has to be subtraction or has to be division. So I'm going to try to see if I can figure out that it is divided by 6 to get from 30 to 5. So that means to get from this answer, I'm also going to do divided by 6. So 36 divided by 6 means that my equivalent fraction is 5/6. I also have to make sure that you know how to take a word problem like Jan ate 3 out of 8 slices of pizza. And then use that to find an equivalent fraction. So it says how many slices out of 16 would she eat? So here's what we're looking at. The first thing that jumps out at me is that there's a comparison. It says 3 out of 8 slices of pizza. So I know that she ate 3 out of 8 slices of pizza. Then it says how many out of 16. So does that mean that the 16 is my part or the 16 is my whole? And if you think about that, you understand that 16 is your whole pizza. We sliced it differently. And then you try to figure out how is it that I can get from one number to the other. So you are looking for relationships here. You know that 8 times 2 gives me 16. So 3 times 2 would give me 6. So the answer to this question is that she would eat 6 slices out of 16. On the next page of your notebook, you're going to get a foldable that looks like this. And I folded it in half and then I cut it on the dotted line. And you're going to glue this in, but you're going to do 3 examples under each one. So I'm going to open this up and I'm going to show you what the 3 examples that you need to do are. Under the equivalent fraction side, you have one that looks like this. 2/9 equals what out of 27? The second one is 48/60 equals 4 over something. And the last one is something over 9 is equal to 15/27. So again, that's under the equivalent fractions tab. Under the simplifying fractions, you're just going to simplify 3 fractions for me. The first one is 17/51. A lot of students think that one is simplest form already because you have a 17, but I'm here to tell you that it is not. The next one is 60/84. And then the final one is 120 over 360. When you're finished, this goes glued into your notebook as instructed on your haiku page. Thanks.